Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Between Two Ferns by Fenners. And here are the rules. We have normal 9 by 9 Sudoku rules apply, which means place the digits 1 through 9 in each row, column, and 3 by 3 box. We have between lines, where digits along a line connected by two bulbs must be strictly between the two digits in the bulbs. And digits can repeat along a line if allowed by other rules. So, for example, between these two digits must be these digits here. So we could have, say, something like 3 and 7 here, and this is 5 and 6. And the digits on the between line are between 3 and 7. So that's an example of how between lines work. We also have extra region construction, where there are nine cell, non-overlapping, orthogonally connected extra regions in the grid that each contain the digits 1 through 9. And extra regions must also be, I think it's an extra B. Extra regions must also be orthogonally connected within a 3 by 3 box. What does that mean? Extra regions must be, oh, okay. Must also be orthogonally connected within a 3 by 3 box. So you can't have a region do something like this. I don't even know. What's an example? What's a potential example? You can't have something like this as a region. 1, 2, 3, 4, 5. That's too many. Maybe, I guess, this. So this is not possible to be a region. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this cannot be a region because in the 3 by 3 box, the region must be orthogonally connected within a 3 by 3 box, and these are not orthogonally connected, which just means sharing an edge in the 3 by 3 box. Actually, that's not completely true for orthogonally connected regions. So let's use this as an example. So this is orthogonally connected as a region, because what does it mean to be orthogonally connected as a region? It means you can go from any cell in the region to any other cell in the region just by going through edges, all while staying within the region. So to get from here to here, that would be valid as a region. To go from here, you can go through the edges going this way, all while staying within the region. Now, the problem is, for this region specifically, is we also have, they must be orthogonally connected within a 3 by 3 box, which means they can go from any cell in the region to any other cell in the region just by going through edges of cells within the box to get to the other cells in the region. So this obviously has no connection to this one, so that can't work in that specific case. But say this is a valid region in general, because in every 3 by 3 box, you have cells which can go to any other cell in that 3 by 3 box just by going through edges while staying within the region. Same with this, same with this, same with that. What would not be a valid orthogonally connected region? Well, I showed one but this is only specifically because the extra region must also be orthogonally connected in each 3 by 3 box also. This is not valid, though, as an orthogonally connected region, because these two cells, while they can get to each other by going through edges while staying within the region, they can't get to any of the other cells in the region by going just through edges while staying within the region. They would have to go through a corner here, or go through an edge here, exiting the region, which is not allowed. So keep that in mind. Digits in a bulb indicate how many cells within a 3 by how many cells in that 3 by 3 box are part of the region that it occupies? Bulbs may or may not share the same extra region, but the line connecting them must never contain cells of the same extra region as either of the connected bulbs. Huh. That's interesting. So digits in a bulb indicate how many cells in that 3 by 3 box are part of the region that it occupies. And that's this extra region. It's not the 3 by 3 region that's normally in normal Sudoku. Okay. So this digit here signifies how many of these digits in this 3 by 3 box are of the same region as it. And so, for example, if this were, say, a 9, all 9 digits in this box would be part of the same region as it, because we have to have 9 digits all be part of this region, this extra region that the cell is in. So all of them would be part of that region in that case. Bulbs may not share the same, may or may not share the same region. So these potentially could be part of the same region, but the line connecting them must never contain cells of the same extra region as either of the connected bulbs. So you could not have essentially a region going something like this, right? Because these can never, the cells on the between lines can never be part of the regions of the bulbs, right? So this is not valid here. Interesting. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, what we know. So let's mark the boundaries of certain cells. This cannot be the same region as that. This can't be the same region as that. Same with basically every between line and their bulbs. So these are not the same region. Therefore, this cell must go down here. So we'll mark that as light. This has to be a separate region. We don't know which one. This has at least 1, 2, 3, 4 unique digits in between these cells. This has 3 unique digits between them. So obviously this is at most a 7 here, because the number of digits that it can't be 7 even. Oh, that's interesting. This is at most 6, and this is at most 6. Huh. Because for digits that can match their region, you can only have 6 at most here. But they can't be part of the same region, because then they would have the exact same number of the exact same digit. So this has to be a different region here. Interesting. Than light or this medium dark. This has to be at least 3 to get out. So it could be 3, 4, or 5 here. This could be 1, and it can't be, it's 1 through 3. And we have 3 digits in between this. So this can never be 3, because 3, 5 do not have 3 digits in between. This has to be 1 and 5 here, right? And then these digits have to be 2, 3, 4. So we have 1 here, and this is 5. So the 5 means all of these are the same region. And this must go out here. So medium has to go out here. This could be part of some completely different region. And we know this is done as a region. Let's go draw a border around the entire grid. So this must be 2, 3, 4 here. Interesting. And the remaining digits in the box are 6 through 9. So the light region needs access to 1 through 4. I'm wondering if I should make this green. Yeah, let's make this green instead. And we'll make this light here. Because green is going to have to get to part of this cell here. This can't be 1. It could be up to 7. No, it can't be up to 7 because, again, you must be orthogonally connected as a region. So this is up to 6 here. So it's 2 through 6 there. This does not have 2 digits here, so this could be up to 7 here. This doesn't have these 2, so this is up to 7 here. And these are different regions, so it can't actually be 7. If it contains 1, it cannot contain the other one here. So this is up to 6. This is up to 8, because it could potentially be all of these. No, cannot be the same region. So circles can never be the same region as each other. So these are necessarily different regions. So this is up to 7 then. We have 1 through 7 there. This has to be between 1 and 7 at most, so this is 2 through 6 here. These are different regions. This has to be a different region, so this is 1 through 7 here, which means this has to be 2 through 6 here. These have to be different regions, so it could be up to 8. It has to go out, so it can't be 1. So this is 2 through 8 there. This is 1 through 8 also. Because, again, it can't be 9, because it can't be... Well, can't be 8 either, because then this would be not having a region. Can it be 7? Probably not. No, if it's 7, then this can't get out. So this is 1 through 6 at most. I guess this could be 7. This can't be 1 because of 1 in the row, so this could be 2 through 9. 2 through... These are separate regions. So these are separate regions here. Interesting. Okay. Can this actually be 6? If this is 6, then the problem is it can't be part of the green region. So I think the answer to that is no. Can it be 5? I don't think so either, right? If it's 5, then this green region isn't fully part of that. It could be 4, it could be 3, it could be 2. So 2, it could be just these 2 and then exit out. And then the green could be good there. 4, it would have to be part of the green region. And 3 could be part of the green region or just an extra and then go out there. That's possible. So this is 2, 3, or 4. We have 2 digits in between. So this cannot be another 2, 3, or 4 here. Because if you have 2 here, that means this is 4 at most here. You only have a 1 digit in between there of 3. Same with this being 4 and that being 2. And then 3 also is the same way. So this can't be 2, 3, or 4. It's 5 through 8 there. That's interesting. Oh, we have a 2, 3, 4 triplet in column 3, which eliminates 2, 3, 4 in the rest of the column. So this has to be not 2, 3, 4. So this is 5 through 9 here. And this has to be between these two digits. So this cannot be 8 or 9. It's 5, 6, or 7, which means this is going to be then 6, 7, or 8 there. It can't, it could be 8. No, it can't be 8 here. If this is 8, the problem is all of these would be part of the same region, and this can't exit out. So this has to be 7 at most. And then this could exit out that way. 1, 2. So that means this can't be 7 here. We have a 5, 6 pair in column 3, which eliminates 5 and 6 in the rest of the column. So this is 7, 8, 9. This must have 5 or 6 here, which means one of these, if this is 6, one of these would have to be 7, because they can't be greater than 7. But then that would eliminate all possibilities for that cell. So this can't be 6. This is 5, which makes that 6, which makes this a 7. So this has to be 7 here. This has to be between 6 and another digit. So this can't be 5. These can't be 6. This can't be 6 here, because it's between, one of these digits is a 6, to be in between the 5 and some other digit. So that means this can't be 6, this can't be 6, because they both see these cells, and one of them is a 6. 5 obviously cannot be one of these two cells. You can't have 1 be here, because that would only have a single digit of the same extra region, which is not possible. This could be 1, though, because it could just exit out that way. So this is 7. Therefore, this must be part of a separate... 7 eliminates 7 in the rest of the box. This is 8, 9 pair, which eliminates 8, 9 in the rest of the column. So that's 7 there. 7 eliminates 7 here. These two have to be then... So 7 must be part of this region, and then we have 2. So this must be 2 here, which makes that 6 there. So 2 cannot be part of the between lines. So this 2 must exit out this way, and that's done. And then the so this is done as a region. And the 7 has to be all of these digits. So that's red. Yellow has to go out that way. 6 contains 6 digits in this region. That's interesting. It cannot be 6 here. This can't be 5 because of 5 in the row. These can't be 2 anymore because of 2 in the row. Yellow cannot go here. Because if it goes here, these would be part of the same region. So yellow has to do something funky like go out there, and then this is part of the same region. I guess, So then yellow has to go out here. Cannot go here because that's a 7. So then red has to go this way. And it can't be part of that region, so red has to go that way. So that's done as a region. So we need 2 with the 8, 9 there. So this cannot be 2 here. Because the 2 has to be part of this for the red region to be full. That's done as a region. This is 6. We have 3, 4, 5 as a triplet in box 8, which eliminates 3, 4, 5 in the rest of the box. This can't be 3, 4. This can't be 2. Wait, that doesn't work. Because that's... What the heck? This fails. Huh. That's problematic. Hmm. Huh. How does that work? Hmm. I must have messed up, but I'm not sure how. This green needs access to a 2, and the 2 in this box is not going to be valid, so it has to go out this way. Which means this is green, that must be 3 here. And we need access to a 2, so this has to be 2 that way. Which means this can't be 2, but it has to be 3. Hmm. This can't even be 7 here. Hmm. That doesn't feel right. Okay, so something's wrong with one of my assumptions, obviously. Let's draw the border around. Bulbs may or may not share the same extra region, but the line connecting them can never contain cells of the same extra region as either of the connected bulbs. So this is still correct. These are definitely boundaries. Hmm. Digits in a bulb indicate how many cells in that 3x3 box are part of the region that it occupies. So again, these cannot be part of the same region. I think this still has to be 1 and 5, right? These are all green. We have light here. This is pink. Two, 3, and 4 are between. Cannot be 6. Because then green, it's too big to be part of green, and then green can't, is only 5 digits. Can't be 5 for the same regioning. It's too big to be part of green. Also, you'd have a repeat as part of green. And it would block the green from being more than 6 digits. So this has to be 2, 3, or 4 here. This can't be 1. Can't be 2, 3, or 4. This is 5, 6, or 7. Because it can't be 8, because then this wouldn't have a region. So in between is what? 3, 4, 5. We have again 2, 3, 4 is a triplet, which makes this 5 through 9. To be in between, it cannot be 7, 8, 9. So it's 5 or 6, which means this is not 6, 5 or 6 there. It's 6 or 7. This can be at most 5 digits. But this is 6 or 7. It cannot be the same region as that. So this must be 2 or 3 at most. This cannot be same region as both of these, so this could be up to 7. 1 does not have 2 unique digits. 5, 6, or 7 is here. So this has to be not 7, 8, or 9. It's 5 or 6, which eliminates 5, 6 in the rest of the box. If this were 6, this would be 7, and they would both eliminate that digit there. So this can't be 6, this is 5, which makes this 6, which makes that 7. So there's no 7 here. This is not 5. This is 7 digits in the same region. And this must be 2. So that makes this 7. Yeah, we still have the same thing. So this is 2. These must all be part of one region. 2 must go out here. This has to be 6. Oh, yellow can be part of the 6. That's how it works. Gotcha. Okay, that makes a lot more sense. This can't be part of that region because of the 7. And we tried going that way. It cannot be part of this because this would be all 6, and then this would have to be 3. But then again, like we said, so this is still valid. So we have 3, 4 here because it must be between 2 or 6. Cannot be 5. This is 3, 4, 5 here. And these, this digit cannot be part of 6, so it's 3 at most. And if we tried to connect the yellow here, these digits, okay, so this digit has to get out. So it's at most, it can't be 7, because if it's 7, these could be completely different. No, it could be 7. So this could be up to 7. This can't be 2 here, but if this is 1, that would be 3 at most here, and then the between line would only have a 2 possible to be on that line, so this can't be 1 or 3. Can you have 4 here? 4. The between lines here have to be 2 through 6. And this can't be 2 or 6 here. No 2 or 6 here because of 2 in the row and 6 in the box. No 2 here because of 2 in the row. So we have a 3, 4, 5 triplet in box 8, which eliminates 3, 4, and 5 in the rest of the box. So this cannot be 3. Which means if we try to connect this way, this would definitely doesn't work. So this is 1 or 2. It's not part of yellow. So then yellow has to go out, and then it has to have at least 3 digits, so it must be part of the 6 here. It's 6 though. It must orthogonally connect. So it could do something like that. It could, so can it? It could be something like this. Can it? It could be even something like that. Ooh. I don't know how that connects then. The red could go over here. We don't know. This has to have 3 digits from 3, 4, 5, and 6. So this has to be either 6 or 7 here. This could be 1 or 2. This is 3, 4, 5 between that. Okay. So we have 2 digits here, 6 digits here, and then we could have 1 more. This has 6 or 7 digits. It does need to exit out. So it cannot do something like that, because if this has to be, Cannot be part of the same region as that. So this is 1, 2, or 3 here. This could be 1 if red goes out here and is 2. This could be 2 separately. And it could be part of red, or it could be part of some other region. That means we have... It could be just 2 that way. This is 1 through 3. This has at least 4 digits greater than it. So this has to be then at least 5. Yeah. 5 through 9 there. This cannot be 6 going that way, so this is part of that region. Can you go 6 going without this cell? No, that's part of that region. What about this cell? No, because then that would be 2. So these are all blue. And then one of these 3 is not part of, or none of them even are part of that region. This can't be 7. If this is 7, this would have to go out that way. This would have 6 digits in the... Actually, I guess it could. That could work. Never mind. This could be 7. Two eliminates 2 here. So one of these 2 is a 2, which means this cannot be 2 here. So this is either 3 or 4. If it's 4, it would have to be part of the green region. If it's 3, it would not necessarily have to be part of the green region. Okay, so this is between 3, 4, and 7. Cannot be 6 or 7 here. So this must be 4 or 5 there. We have a 3, 4 pair in column 2, which eliminates 3, 4 in the rest of the column. This can't be 7 either. That makes this 5. So we are guaranteed 7 here. Remaining digits of column 2 then are 1, 6, 8, and 9. And 6 cannot be here because of the 6 in the box. So we're guaranteed a 6 here, which eliminates 6 in the rest of the box. Remaining digits of box 7, we have 1, 3, 4, and 6. 6 cannot be here. So we're missing 2 and 8 and 9. So if this were 2 as red, it would have to be with 8 and 9 here. If this is 1 as red, it would have to go here, and then 2 would... Wait, no, that can't work. Interesting. So this can never be 1 then, because if this were 1... it can't be part of red, but then that's the only way it can exit out by itself. So therefore, this is 2. And it could be 2 and part of this as different digits. Or it could be part of the red and would have to go that way. Remaining digits of column 1. We have 2... and 1 of 3 or 4, and 1 of 8 or 9. Interesting. So this is never going to be part of this red region. So this is a boundary. These digits in between have to be 2 through 8, which is not very restrictive. This can't be 6, this can't be 6. No 6 here, no 6 here. Oh, wait, this can't be 5. It has to be at least 6 through 9 here, because if it's 5, the difference between 5 and 1 are only 3 unique digits, which is not possible. This can't be 5 or 7 because of 5 or 7 in the row. No 5 or 7 there for the same reasoning. This can't be 2 because of 2 in the column. Um, hmm. Um, hmm. I think this is always part of green, right? If it's not part of green, it's 3 or 4. Well, if it's 4, obviously, then green can't be a full region. And if we tried 3 here and then green going this way, the problem is green and red are not part of the same region. So yeah, this has to be part of green. So this is definitely part of green, which means it connects that way. So this cannot be 8 or 9 because 8 and 9, 6, 7, 8, 9 is already all part of green. So this must be 1, which means this can't be 1 here. This is not part of that region then. So this cannot be 8 or 9. So green has to go at least to here. And then it could go to here or it could go to here. This can't be 8 or 9 for the same reasoning. So these two are not part of the same region. So this pink must go out this way. These two are parts of different regions. If this is 3, we don't know what that is. So green could go either to here or here. Ah. Okay. For this green, if it's only 3 here, this has to go out this way and cannot be a 2. So therefore 2 would have to be there. Otherwise, this is 4, and then it would have to be here, and then one of these would be 2. So we're guaranteed one of these is 2. This cannot be 2 here. And this 2 must be part of the green region, which means the red region cannot access a 2 in box 4. It must access the 2 in box 8. So it has to go this way, so it must be 2 with 8 or 9, because that's the only remaining digit left. This then has to is full as a region here. This is full as a region here. 6 has to go all the way around here. So this cannot be 1 as a digit. It has to be at least 2. And it cannot be, it could be 3 if it's like that. That's, oh. This has to be part of, oh. So this cannot be part of this region, because that would then be 3, and then it can't exit out, because that would not be part of yellow, because yellow already has 8 cells in it. So this has to be part of yellow, which means this can only be 6 here and 2 here. So this is 6, this is 2. 6 must exit out, 2 must exit out. So we'll make that orange. This has to then all be blue, and blue has to exit out. So that's done as a region there. This is between 2 and 6, so this cannot be 6. It's 3, 4, and 5 as a triplet. The remaining digits in the yellow region are then 1, 7, 8, 9. So yellow's done as a region also. Blue has 1, 2, 3, 4, 5, 6, 7. It must exit out, so that must be blue there. This is not part of that orange region, so that's a boundary there. This exits out that way. This can't be 2. So this is between 2 and this digit, so it cannot be 6. Because we have at least 3, 4, 5, 6 here. We can't actually have a 6 here. Because 6 cannot be here or here. So these can't be 2 anymore because of 2 in the box. So this is at minimum 3, 4, 5, and 7. which means this can't be 7. So this can't be 2 because of 2 on the in-between lines. So this is 8 or 9, which means this is all part of the same region as this. And then one of these could be not part of that region. Okay. Hmm. Interesting. Okay. Orange does have to go out this way because there's no other path for it. So blue has to finish off that way. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. So blue is done as a region. This cannot be some other region, so this must be dark. Because if it tried to be part of another region, it doesn't exit out because you have to have 8 here at least. This could be part of another region. Orange, actually, where can orange be? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. It cannot be part of any of the between cells. So this is guaranteed then to be orange, which means this is 8 as a region. So then we have dark here. So this is boundary this way. That's funky. That's pretty cool though, actually. 8 is in between this, so these digits must be between 2 and 8. So there's no 8 in any of the cells. So we have a 3, 4, 5, 7 quadruplet in box 5, which eliminates 3, 4, 5, 7 in the rest of the box. So the remaining digits are 1, 2, 6, 8, 9. We can't have 2 or 1 here. 2 because of the orange region. 1 because of 1 in the row. This can't be 6 because of 6 in the row and column. This can't be 2 because of 2 in the column. So this is 6, 8, or 9. It cannot be part of green because we have 6, 7, 8, 9 already part of green. So this is a boundary here, which means this must be 4. And it has to have 2 and 3 as part of its region. That means this cannot be 2, 3, or 4. It's 8 or 9. So this is boundary here. This is interesting as a region. We have a medium, so this is 8. This could be part of the pink region. No. 1, 2, 3, 4, 5, 6, 7, 8, 9, technically, but this is 6, 8, or 9. So the problem is if it tried to be part of this region here, that's too big. Because then it just can't be part of this as a whole, but it could be divided into multiple parts. These are necessarily part of different regions. So they add up to it. So one of the dark has to be here. Can this be part of this region is kind of the question. 1, 2, 3, 4, 5, 6, 7, 8. And the answer is no. So the light region has to get out somewhere. And it cannot be part of this. Because then that would be too few. If we are part of this region, we have 1, 2, 3, 4, 5, 6, 7, 8. But then one of these must be dark. I guess it could be 8, 9. That could actually work. Huh. Never mind. That could actually work. 8 eliminates 8 as a possibility here. Remaining digits of row... Okay, so how many digits can this be part of? We don't have 1. These add up to 8 at most. So we have 1 through 7 here. No 1 here, no 6 here because of 1 in the row and 6 in the column. No 2 here because of 2 in... This can't be 1. So since this can't be 1 here, this can't be 7. Can this really be 1? No. It can't. It just exits out and it's not part of our region, really. Therefore, since this can't be 2 here, this can't be 7. This can't be 1, this can't be 7 there. Hmm. Can this ever actually be 3? If this were 3, it would be part of the pink region. Actually, if it's 3, 4, 5, it's part of the pink region. And if it's part of the pink region... Okay, it can't be part of any other region besides pink or light, right? So, if it's part of the pink region... If it's part of the light region, it has to be 6. And then it would have to do that. If it's part of the pink region, the problem is if we have 3, so say we had 3. You cannot close off the light region. So you would have to go this way. You can't be part of this cell. And then the light region would have to go around here, but to be a full region, it would block the dark region as a set. So pink cannot go this way. It must be part of light. And therefore, it's 6. Because it can't be 2, 3, 4, 5. Right? Because these are part of the light region. Oh, it could be 5. Okay, so this is 5 or 6, then. Right, because the light region only has 2, 3, 4. And it sees these part of this region for here, and then this has to be part of the light region. Otherwise, this has to be light period no matter what, because it can't be any other. It can't be part of dark, and if we try to exit out, it can't exit out as its own region. So it has to be pink or light. And we've ruled out pink because if we try to go pink, it has at least 3 digits here. So it has to go that way, and then light would have to go around here, but that would block dark from being a full 9-cell region. So this is light, which is 5 or 6. This can't be 5 or 4 then. Actually, it could never... Well, it could have been 4 if this was low, right? But to be with 5 or 6, you have to have add at most up to 8. So you could have 2 and 6 or 3 and 5, and that's it. Light cannot be just 5 because we can't exit out as light in this region because we're blocked here. So therefore this must be 6, which makes this a 2. We have 1 dark here. So light has to go all the way around here. So this must be light because this is not part of the same region. To be 2, this must be part of pink. So that's done there, and this must be dark as the final cell. So that's done as a region there. This cannot be 3, 4, or 6. So this has to be 5 or 7. We do have a 2 for the pink region here. So then the question is, how does this divide up into regions? Can this be pink? The answer is no, because then this would be dividing up into a smaller region here or a smaller region here. Either way, it just doesn't work, right? We have 1, 2, 3, 4, 5, 6, 7, 8, and then 9, and that's not part of a region. Or it just goes straight down, or it tries to go that way. This can't be pink, so this must be medium. I guess we could make this medium and then this pink here. Because that sort of matches where the colors are in the grid. So this must be pink and exits out that way. Remaining digits in the light region have to be 1, 5, 7, 8, 9. And 5 cannot be here. That means that leaves a 3, 4 pair remaining in box 2. So this is 3 or 4 also. 6, 8, or 9. 6 eliminates 6 as a possibility here. So where is 6 in box 1? It must be there. We have a 3, 4 pair in row 3, which eliminates 3 and 4 in the rest of the row. Also, we have a 3, 4 pair in row 1, which eliminates 3, 4 in the rest of that row. So this can't be 3 or 4, it's 2. That means this can't be 2. So these 3 4s, we don't know which is which, but this has to be 5, 7, or 9 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's possible. Or it could be part of this. So pink needs access to a 2. So pink necessarily must go either here or... Okay, this can't be 2. Where is the 2 in box 5? It has to be here. So this is 2, which means it must be part of pink. Which means pink cannot go around here. This has to be part of pink because if we had tried to have it as part of medium gray, it's going to be blocked from connecting. So this is pink, this is pink. So we have full pink there. Medium gray cannot go as a whole for this one. So we have 1, 2, 3, 4, 5. Can this not be part of medium? I think it has to be part of medium, right? So if we try to go around, it doesn't work because so this must be part of medium. Therefore, medium cannot go fully here. Can't get reached here because then the problem is we have a 6, 8, 9 triplet as part of the region to connect. And this is already guaranteed to be 6, 8, 9. So this cannot be medium. This is pink, which makes that pink, which means that's pink. So we have 8 cells in the pink region. That means this must orthogonally... You can have 1 at most here. So pink cannot be here or here. So these must be medium. Therefore, this can't be 6 here. So that's 8 or 9. Because if we had pink here, that would block this cell from having a region at all. Same with this. That would block these 2 cells from having a region, because if that were pink, medium couldn't get through there. This is pink or medium here. We're not sure which. This can't be pink for the same reasoning. If this is pink, then this doesn't have a region. So this is pink or medium, and these have to both be medium. Well, 1 here eliminates 1 from being here. This is 8, 9 as a pair, which eliminates 8 and 9 from the rest of the region. So this cannot be medium, it's pink. This can't be pink, it's medium. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 cells there. And that's done as a region. Where's 1? We have an 8, 9 pair in the pink region. This cannot be 8 or 9. And this can't be 5 because of 5 in the region. So we have 3, 4 as a pair in the pink region. This can't be 3 or 4. It's 6. This can't be 6. It's 1. This 8, 9 pair eliminates 8 and 9 in the rest of the box, so this cannot be 8 or 9. It's 6. Okay, we have a 3-4 pair in column 4, which eliminates 3-4 in the rest of the column, so no 3-4 there. It's 5 or 7. 1 eliminates 1 in the rest of the column, so this can't be 1. This can't be 1. So we have a 7, 8, 9 triplet now in column 4, which eliminates 7, 8, 9 in the rest of the column. So this can't be 7, it's 5. That eliminates 5 in the rest of the box. One in the yellow region must be one of these two digits. So that eliminates 1 in the rest of the column. So this can't be 1 here. We have a 3, 4, 5, 7 quadruplet in column 6, which eliminates 3, 4, 5, 7 in the rest of the column. So this can't be 5 or 7. There's no 7 here. So we have a 1, 8, 9 triplet in the yellow region, which eliminates 1, 8, 9 in the rest of the region. This can't be 8 or 9. It's 7. That eliminates 7 from being here. We have an 8, 9 pair in box 2, which eliminates 8 and 9 in the rest of the box. Okay, remaining digits, this can't be 3, 4, or 6 because of the 3, 4, 5 triplet in the row. So this has to be 1. That eliminates 1 from being here or here. This 2, 3 pair eliminates 2, 3 in the rest of the column. So this can't be 3, it's 4. This can't be 3 or 4, it's 6. 4 eliminates 4 here, so that's 3, which eliminates 3 in the rest of the column. So that's 4. This is 3. 4 eliminates 4 here, so that's 3. This can't be 3 because of 3 in the column. 4 eliminates 4 in the rest of the medium gray region. So this is 7. This is 3. 7 eliminates 7 here, so it's 5. 5 eliminates 5 in the rest of the column, so it's 4. This can't be 3 or 4. This 3 eliminates 3 here, so that's 4. This can't be 3 or 4 because of 3 or 4 in the column, so this is 5. Can't be 5 or 4. It's 3. 5 eliminates 5 here. 3 eliminates 3 here, so this is 2 and 3. Okay. 2s. We have a lot of 2s. Where is 2 in row? Well, in the blue region specifically. 2 cannot be any of these digits. 2 can't be here or here because of 2 in the rows. So 2 has to be here. And we have 8 2s now. We know where the last 2 has to be. It has to be there. We have an 8, 9 pair in row 2, which eliminates 8 and 9 in the rest of the row. So this can't be 8 or 9. It's 7, which makes this 9, which makes that 8. That 8 eliminates 8 here, so that's 9, which makes that not 9. So that's 8, which makes that 9 there, which makes that 8. Which makes that 9, which makes that 8. 4 eliminates 4 here, so that's 3. 9 eliminates 9 in the rest of column 6, so this is a 1, 8 pair, which eliminates 1 and 8 in the rest of the box and region, so this can't be 8, this is 9. 5 eliminates 5 here, so that's 1, 7 as a pair. 9 eliminates 9 in the rest of the red region, so that's 8, which makes that 9. That leaves 8 remaining in row 9. Remaining digits of row 5 are 1 and 4. Remaining digits of the orange region, then. Okay, so remaining digits of row 6 are 3 and 9. And this cannot be 3 because of 3 in the column. So this is 9, that's 3. 8 eliminates 8 here, so that's 1 and 8. Remaining digits of row 7 have to be 5 and 9. And this can't be 9 because of 9 in the column. So this is 5, that's 9. Remaining digits of 3 eliminates 3 here, so that's 4, which makes that 3. 7 eliminates 7 here, so that's 1, which makes that 7. Remaining digits of row 2, we have 4 and 5. Either of them could be 4 or 5. Remaining digits of row 1, we have 1, 6, and 9. 6 cannot be here or here, so 6 has to be here because of 6's in the columns. And 9 here eliminates 9 here. So that's 1 and 9. 1 eliminates 1 here, so it's 4 and 1. Remaining digits. So we should have 8 ones. We do. We know where the last one has to be. It's there. Threes. We have 1, 2, 3, 4, 5. So we have all 9 threes. 4. Where is 4 in row 8? Cannot be here because of 4 in the column. So 4 has to be here, which forces this to be 5, which forces this to be 4. 9 eliminates 9 here, so that's 7. So we should have all the 4s. 5s, we have 8 5s. We know where the last 5 has to be. It has to be there. 6s, we should have all 9 6s. We do. 7s, where is 7 in row 8? It must be there, and that gives us 8 7, so we know where the last 7 is. It's there, which forces this to be an 8. Not too bad. This is basically just, it's essentially chaos construction within a normal Sudoku. So that's the way I view extra region construction. It's basically chaos construction, but we also have the limitations of normal Sudoku too. Yeah, I almost messed up by this part here. Well, I did leave that bad assumption here, and I was just confused by that. So obviously, it had to be part of this region because of that. I don't know. Sometimes you'll come into those sort of eureka moments just by running into the problem itself over and over again and just going, oh, well, this has to go this a different way, right? I guess it's always just something that you have to pay attention to. You might be making some bad assumptions somewhere in your calculations, so you have to keep that in mind. And sometimes just doing a full reset is just the best way of doing that, because then if you run into the same problem over and over again, you'll eventually realize, okay, I'm making some sort of bad assumption. But sometimes it doesn't work out. There have been puzzles that I've tried many, many times, and I keep running into the same issue. And I don't know. I'm not sure what situation that happens to most people, but it can be frustrating if that's the case. But sometimes if you start over, you'll find the solution, because you'll be like, oh, I made that bad assumption, so I had to go somewhere else. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.